there, this is Dr. May. We're going to take a look at a couple of examples with problems with systems of equations. Now, I have three different problems here, and we're going to take a look at how you would answer each and every one of them. So let's take a look. In the first problem here, we are looking to see if 5(1) is a solution to the system x minus y equals 4 and 2x plus y equals 5. Now, in order for 5(1) to be a solution to this system, we must be able to substitute in 5 for x and 1 for y and get true statements. So let's take a look. So if we replace x with 5, we get 5 minus 1. We replace y with 1. And 5 minus 1 is 4. That works. But it's not enough that it works in one of the equations. We have to make sure it works in the other equation as well. So in our second equation, we're going to substitute in 5 for x and 1 for y. Now, notice that when I have 2 times x, that means 2 times 5 now. So 2 times 5 is 10, and 10 plus 1 is not 5. So that means that this is not a solution. 5(1) is not a solution of this system because it only produced one true equation, not two. Let's look at the second problem next. When we have a system of equations, we have two lines graphed, we get three types of solutions. So the first graph that you see here are where two lines intersect. Now I'm just drawing a sketch here. So you can kind of put this like in your notes. And so in this case, you see that the lines intersect, and where they intersect would be the solution. So we would get one solution here. And in fact, in this graph that you're given, you can see that the intersection is at 2, 2. And so that would be my solution for that graph. Now, on the second graph that we're given, there are actually two lines being graphed here, although it only looks like one. I want you to see that the two lines are actually right on top of each other. So I've got one line and then another line that graphed right on top of it. So when the two lines graph right on top of each other, that means we have infinitely many solutions. Now, the last example, we have two lines graphed, but they are parallel. You can see that these two lines are not going to touch. And we already talked about the system having a solution where the two lines intersect. Well, these two lines don't intersect, and that means we have no solution. So anytime you're using the graphing method to solve your system of equations, you're going to get one of these three scenarios. Either you're going to get a point where the two lines intersect, or you'll have the two lines graph right on top of each other, or you'll graph the two lines and they don't intersect at all. All right, let's look at our last example here. We are going to solve this system, and we're told we have the freedom to choose any method that we would like. But I'm going to try to choose the wisest method for this system. So you can see that my system has x's and y's in it. And I think I'm going to use the elimination method. And what I'm looking at here is I can see that if I could get a 2 right here in front of this y, then I could eliminate the y's. So let me multiply this first equation by 2. See my little arrow here and my times 2 is just a little note to myself to remind me what I did there. So 2x times 2 would give me 4x. And 2 times y would give me 2y. And 3 times 2 would give me 6. Now, my second equation, I'm just going to rewrite it because I didn't really do anything to it. And now I'm going to add the two equations together. 4x plus 3x gives me 7x. My plus 2y minus 2y cancel out. And my 6 plus negative 20 gives me negative 14. And now I have this equation 7x equals negative 14. So I can divide both sides by 7. And now I see that x equals negative 2. That's a really good thing because that's one of my solutions. However, it's not the entire solution. So my final step is to take the one of the equations. I'm going to choose that first one only because it looks a little bit simpler. And now I'm going to take this x equals negative 2 and I'm going to substitute it in for my x. So again, 2 times x now looks like 2 times negative 2. 2 times negative 2 is negative 4. And now I have this equation, negative 4 plus y equals 3. So I'm going to add 4 to both sides. So I get y equals 7. Now I know what x is and I know what y is. So I've got my solution, negative 2, 7. I want you to notice that I wrote it in alphabetical order, x and then y, to give my final answer.